Hello everyone! Today I'd like to tell you about such a metal as ruthenium, which has recently received heavy coverage in the mass media. In the periodic table of chemical elements, it belongs to the so-called platinum group, which unites metals, chemicals and physical properties of which are similar, and also those metals that are commonly found together in their naturally occurring minerals. Ruthenium is extracted from platinum ores. There are lots of ruthenium-rich deposits in the Ural Mountains and also in the mountains of South and North Americas. By the way, pure ruthenium was first extracted from Ural ore by Russian scientist Karl Ernst Klaus in the Kazan Federal University. He named the element after his motherland, Russia. The pure extracted ruthenium is a shiny and heavy metal with a quite high melting point, 2334 degrees Celsius. As some of the split ruthenium balls indicate, this metal is quite fragile and almost can be forged. From a chemical point of view, however, this metal is very similar to its platinum fellow metals belonging to the platinum group. That is why it doesn't react actively with most chemicals. This property of the metal can be used to grow beautiful metal crystals of ruthenium. The crystals form when ruthenium particles are transported as a gas in vacuum and at high temperatures. Such crystals don't have oxide coating. That is why they look stunning. High-resolution macro photos of such crystals look particularly interesting, especially when crystals glitter in coated jaw lighting. Ruthenium almost doesn't oxidize in air at room temperatures, so minor changes occur only at high temperatures. After heating up with a gas burner, ruthenium crystals start covering in multicolor ruthenium dioxide layer. Its thickness is extremely small. Because of being very hard and very corrosion resistant in air, this metal is often used to coat the surface of electrical terminals in order to prevent them from getting oxidized and worn out, thus ensuring a reliable connection. Pure metallic ruthenium is also added to superalloys of nickel with aluminum, which can withstand high pressure at high temperatures. These alloys are used to make blades for jet engine turbines. Being so chemically inactive, ruthenium is also doesn't react with acids. It doesn't dissolve in any acid, not even in boiling aqua regia. Anyways, this noble metal can easily oxidize in plain chlorine bleach solution containing sodium hypochlorite and traces of alkali. It can be clearly observed that upon heating up, the metallic droplets slowly start to dissolve, giving the solution brown color. This reaction produces sodium rutenates and perorutenates, which are quite necessary compounds nowadays. If sodium is substituted with bismuth in such compounds, you'll get bismuth rutenate, a chemical used with ruthenium dioxide to make thick film miniature resistors, which are used in a lot of smartphones and also hard miniature electronics. Later, when the rutenates in the solution react with hypochlorites, they can form dark ruthenium tetroxide. The highest oxide of ruthenium is often used in organic synthesis because it can oxidize any hydrocarbon. I think you have noticed that ruthenium has more application in the form of compounds rather than in the form of pure metal. Since recently, metal organic compounds of this metal have gained a great deal of popularity. For instance, oxidation state of ruthenium in tris-bipyridine ruthenium chloride is 2. This so-called coordination complex is being extensively studied by scientists because of its photochemical properties. First of all, this substance glows well in ultraviolet light. Besides that, it can also catalyze chemical reaction when exposed to ultraviolet light. For instance, it's the case when water is oxidized to oxygen with oxidizing agents, or when water is reduced to hydrogen with the presence of this ruthenium complex. Apart from that, this ruthenium compound can also be used to make more efficient thin film solar cells and also to make flexible LED displays. Such ideas, however, have not found widespread use. I think it's so because of the high cost of this metal and perhaps because it may be toxic to humans. It is noteworthy that there exist a few articles that speak about how ruthenium metal organic compounds can cure cancerous tumors. Until now, I have been telling you about the ordinary, non-radioactive ruthenium that consists of 7 stable isotopes that occur in nature. However, there exist 27 more radioactive isotopes of this metal. One of the most widely known of them is Ruthenium-106, which forms as a result of radioactive decay of uranium in nuclear reactors. This isotope can be separated out from others and be used to treat eye cancerous tumors with low relapse rates. Russian Rosatom also produces this isotope. In the end of 2017, there was made a lot of noise in the mass media about supposed Ruthenium-106 contamination cloud above Europe. At first, Mayak nuclear plant in Ural Mountains was under a cloud of suspicion, but Russian authorities denied their involvement and officially claimed that the contamination was caused by a satellite that burned down in the atmosphere. Unfortunately, I haven't found any information of satellites that use ruthenium isotopes as radioisotope energy source. If you know something about it, please leave a link down in the comments below. Nevertheless, the disputes about Ruthenium-106 cloud above Europe are still ongoing. I'm not making any claims and not taking politics here. I'm just sharing information from the open sources. It is up to you to make any conclusions. Nevertheless, in spite of having a reputation of unstable isotopes, non-radioactive ruthenium is used in a wide variety of applications. Perhaps, in the future, these metals compounds will be used in the new solar cells or in efficient light-emitting diodes. Anyways, as they say, wait and see. For the provided ruthenium for the experiments, I'll thank the company onyxmed.com. I'll put a link to their site in the video description. Now you know a little bit more about one of the other metals. If you would like to support the continuous production of science videos like this one, please support channel on Patreon, link in the video description. Please like this video and subscribe to my channel to see many more new and interesting